All right, so we're continuing on with geometric patterns. This time again, we're looking at a series. So again, the difference between a series and a sequence is that now we're adding up those terms. So again, we're going to look at having your sum of a certain amount of terms. That's what our n is there. And again, you're adding, I'm listing the terms, but I'm adding them up as I go along. So that goes all the way to our final term, which I don't know what it is, so I'll call it Tn. So again, that is the sum of a geometric series. Now we have a specific formula for a geometric series, just like we did for a arithmetic one. And so our formula, why don't I get a nice little fancy color here? I have Sn is equal to A, and then in brackets, R to the power of n, then minus 1, all over r minus 1. There we go. So there is our formula for finding the sum of a geometric series, all right, which again is the total or adding up all the terms in that series. And so I get to example 1, little genealogy here, and that what it looks at is a big long question here, so I'll read it out. Definitely can't write it. I filled up the whole board here. But some families, and I've done this, succeed in tracing the roots back 10 generations. Can't say I did that, but that far, or more. Now, when you go back 10 generations, how many ancestors would you have? So you start off, there's a sequence here, is that you start off with 2 parents, all right? And each of those parents have parents, and so the next part of your generation is you would have 4 grandparents. All right, so we have parents. There's our grandparents. And then each of those grandparents would have parents. So there would be 8 total great-grandparents. So great-grand I'll throw in there. And each of those people would have parents. So you double it up again, so plus 16. And we could keep going on and on and on with that. And what we're looking for is, what would the sum of 10 generations, how many ancestors would you have 10 generations back? And so what we're looking at is finding S of 10. Now, if I'm using my summation formula over there, again, because we're finding how many ancestors we have 10 generations back, our n is 10. We're going to add up the sum of the first 10 terms in this sequence. Now, again, a couple of other variables we need is the a, the first term. Well, the first term is 2. All right, and then lastly, we need the r value, the rate. And again, sometimes, not all the time, well, most of the time I would say the r value is not easy to see, right? I go from 2 to 4, 4 to 8, 8 to 16. I think this one's a little bit easier, but again, if I want to make sure, I take any term and divide it by the one before it. So I could take this 8 and divide it by the one before it. And 8 divided by 4 is 2, because we're doubling each time that we go through this scenario. All right, so now I have my information that I need. I'm trying to find the sum of the 10 generations, and so I'm going to substitute it in my formula over there. So I have S of 10 is equal to my a value, which is 2. And then in brackets, I have r to the power of n. So in this case, it would be 2 to the power of 10, then a minus 1 here. And in the bottom, I have r minus 1, which is just a 2 minus 1. All right, and so again, just following Bedmas. And so, well, I got to go inside the brackets here. Got to do that exponent. 2 to the power of 10. That is, let me see here, calculator, 1,024. And of course, I got this minus 1. Down the bottom, well, 2 minus 1 is 1, so it's not even really a fraction anymore. All right, and let's see here. So I have S10, S of 10, so we got 2 times, well, 1,024 minus 1 is 1,023. And again, I'm not worried about the 1 in the denominator anymore because anytime you divide by 1, you just have the same thing. So then 2 times 1,023, that should be 2,000 and double 23, 46. And so if you go 10 generations back, you would have 2,046 people that are related to you. All right. In my case, I can only go back about 6 generations or 5 generations because of the great Irish potato famine. There's no records. Everybody took off from Ireland back in those days. So there's no records. They left them in Ireland. And everyone left, so I don't know. Who knows what happened to them. All right. So let's try a couple more of those. All right, so example number 2. So we have a different geometric series here. All right, so I'm going to need a new pen here because it's terrible. So I got 2 minus 6 plus 18 minus 54 plus, and it just keeps going on and on and on. So clearly this one's a little bit different because the signs are switching, right? And this is something we haven't had yet. But again, this question is asking for us to find the sum of the first 8 terms. All right, so that means the total number of terms we're adding up. 8 is 8. So there's our n value. My a value, again, that's always the easy one, right? It's your first term. So it's 2 again. Now, here's my r value. Again, define the r value, pick a term, divide it by the one before it. So I'll pick 18. I'm going to divide it by the one before it, but I got to watch the sign here. There's a minus 6 there. And so my r value is 18 divided by negative 6. That's a minus 3. And that's why the signs are alternating, because my rate is negative. So negative times a negative flips it to positive, but then you times a negative again, flips it to negative. So it just keeps flipping, positive, negative, because our rate is negative. So we haven't had that before. All right, but what I do now have is everything else is the same, is that I've got all my variables. So I'm going to use my summation formula over there. So I have S of 8 is equal to, again, my a value is 2. All right, now in brackets, I've got an r to the power of n. I got a negative 3 here, so I'm going to make sure I put that in brackets. To the power of n, which is 8, minus 1. All right, and then again in the bottom, I've got that, I got 2 minus 1 again. Good. Denominator's going to be 1 again, so I don't have to worry about it. All right, so Bedmas, again, I'm going inside those brackets. So I got 2. So I got negative 3 to the power of 8. So negative 3 times negative 3 times negative 3 times negative 3. And I end up getting 600 or 6,561. Well, that's convenient because I'm actually going to subtract 1 afterwards. So again, something key here to try out when you get a chance is negative 3 to the power of 8. When you type that into your calculator, you have to put the brackets around that negative 3. If you do not, you'll end up getting negative 6,561. So something to watch out for. Now again, my denominator here, 2 minus 1, that's just a 1. I don't have to worry about it because, again, anything divided by 1 is itself. All right.
Should it be negative 3 minus 1?
What's that, right up here?
Like dividing by, shouldn't it be negative 3 minus 1?
Up top here?
On the bottom.
Oh, thank you. Man, you just saved me a mistake. Yeah, see, there we go. I jumped the gun. Thank you. Negative 3 minus 1. So yeah, now I guess I do have to worry about the denominator. There you go. Thank you. Save me some erasing to do. Again, I don't look at my answers. I think it's always beneficial when I work through the questions myself, so you can actually hear what I'm thinking while I'm doing this stuff. I don't sit there and copy my answers off. So thanks. Save me a little bit of a break. All right. So but I'm going to keep trucking along here. Well, again, 6561 minus 1. Well, we're going to have 6560 then. And I can't forget my -4 in the bottom. All right, so now I'm just going to go 2 times 6,560 divided by -4. So I'll tell you what, I know the answer. It's actually going to be negative, which is weird in this situation, right? Because we're adding positive and negative numbers. So we're back and forth, right? So you go 2 minus 6, you're at -4, then you add 18, you're back to positive. But in this case, the sum of our first 8 numbers, I put the numbers in my calculator and I get negative 3,280. There we go. So that's possible to have when you're adding numbers up, to have a negative sum. Because again, we're flipping back from positive to negative. Probably what's happening with this series is that last term is a big negative number. All right. All right, let's try a couple more. A little bit different this time out. I'd like to switch it up. Or maybe not. Let's see here. A little something. Last one I'm switching up. Leave our formula there. We're going to need that. All right, so next up, we're again finding the sum of a series here. So this example 3. So here's our geometric series. We have 200 plus 100, getting smaller here, plus 50, plus 25, and it keeps going. And again, I'm looking for S of 8. All right, so again, we got to find our values there. We know we're looking for S of 8. All right, so again, well, at 8, so I'm looking for the sum of the first 8 terms, so that means my n has to be 8. All right, A again, always the easiest one, right? It's the first term, 200. All right, now, notice how my numbers are getting smaller. So I'm throwing every different scenario out here. But again, if you want to find an R value, take any term divided by the one before it. I'm going to go with the smaller numbers. I'm going to go with 25 here and divided by the term before it, which is a positive 50. And, well, when I take 25 out of 50, that's 50%, or as a decimal, 0.5. All right, so that's why our terms are getting smaller, because our rate is a decimal, or less than 1, I should say. All right, so now I'm going to substitute in my formula once again. So I got S of 8 I'm looking for here. My A value is 200. All right, then I got R to the power of n, so I've got 0.5. And the n is 8. Whoops, minus 1. Make sure I get that minus 1 in there. This time I won't mess up the denominator, R minus 1. So I got 0.5 minus 1. There we go. So I've substituted incorrectly. All right, so I'm going to have to do, again, badness. Got to go inside the brackets, do the exponents. All right, so I get 200 here on the outside. 0.5 to the power of 8. Definitely a little calculator work there. And I get, I do definitely get a decimal, 0.004 minus 1. All right, my denominator, I take a half on minus 1. I'm down a half now. Okay. Again, let's go inside the brackets here. I take 0.004 minus 1. That's going to be 0.9 something, I think. All right, so I got S of 8. 200 times, that's going to be negative for sure. I type that into my calculator. I'm getting 0.996. All right, again, divided by negative 0.5. And then lastly, whoa, nice S. Doing the math, take 200 times my decimal, negative decimal here, divided by my negative decimal here. Well, I know positive times a negative is negative, divided by negative, it's going to be a positive answer. And so I type that into my calculator. and I end up with 398.4 would be the sum of the first 18 terms of this series. I always say series. All right, so there we did a normal one for example 1. B, we did a R value where it's negative, so the signs are flipping back and forth. And then here we did an R value that's say smaller than 1, which means our numbers are getting smaller. All right, so here's the next one we're going to try out. Now it's a little bit different. Now we did something like it with an arithmetic series, but again, it's different because we're dealing with geometric multiplying, not adding. All right, so here we go. Find the sum. This is example 4. Find the sum of, here's a sequence here. We got some fractions going on here. So I got 1/16 plus 1/4 plus 1 plus 4 plus da 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 da. And we know the last term actually, which is 65,536. All right. So there we go. There is our series. All right. Now, fractions. I don't like fractions. I don't think anybody does. I know 1/4 as a decimal is 0.25. 1/16 is, let me see here. That's going to be a weird decimal. 1 divided by 16. I get 0.0625. There we go. All right, so we'll get rid of the decimals there, or get rid of the fractions. Convert them to decimal. Because again, a fraction is just a divided by question. It's not done yet. Now, if I'm using my summation formula over here, right? I need my A, my N, and my R. A, my N, and my R. Now, A, first term. I got it. That's that decimal. 0.0625. One down. R. I can find the R out. Again, find one term divided by the one before it. I don't want to mess around with these decimals. I'm just going to take 4 divided by 1. Right? Take 4 divided by 1. Well, that is 4. All right, so my ratio is 4. Or my rate, I guess I should say 4. Keep multiplying by 4 as I go up. Now, here's the problem. The N. I don't know how many terms there are. So that's the twist here. I got to find out how many terms there are. Now, I do know the last term, right? So if I figure out which term that is, they say it's the 12th term. Well, then because it's the last one, there is 12 terms. So I'm going to look at my Tn here, my nth term, which is 65,536. All right. Now, again, I don't know what the n value is for it. I do know A. I'm just rewriting my values from over there, and I do know my R. So here's what I'm going to do. I'm going to use the general term formula that we had just earlier today to find out my n, because I know the term, I know the A, I know the R, I can find the n. And so again, the general term formula is Tn for geometric sequence times R, or A times R to the power of n minus 1. So I know this term that I'm talking about here, my Tn, is 65,536. I know my A value here is this decimal. I also know I'm running out of room here, so hopefully I'll make it all right. So 0.0625. My R value again is 4. Sorry if this is a little jumbled. There we go. To the n minus 1. All right, so what I want to do is solve for n, solve for an exponent. Exponential equations, right? But it's going to be a little bit easier than that. Now, first thing I'm going to do to solve for n is I'm going to get rid of this decimal. It's going to thorn in my side. So I'm going to divide both sides by 0.0625. All right, so they divide each other out. And so, well, on the right-hand side, I've got 4 to the power of n minus 1. 65,536 divided by this decimal. It's going to be a big number. So I go to the calculator here, and I get 1,000,000. Yeah, that's a big number. 48,576. All right, now there's a couple of ways to do this. Again, we're solving for an exponent. Now, if you're really stuck, you can use logs. We do that in exponential equations. Solving for an exponent, you can take the log of both sides. But here's the best part about dealing with a geometric series, is that the end value is the number of terms. It is always, well, it has to be a whole number, because again, it's like when somebody asks me how many kids I have, nobody ever, or anybody gets asked that question, they never say, I have 2.5 kids. You either have 2 kids or 3 kids. This is one or the other, right? So what I can do is 4 to the power of something is going to give me 1,048,576. So I can use trial and error with my calculator. Or again, if you like logs, you can take the log. But again, because n is always going to be a full number, I can figure out what's happening there. All right, so you can try 4 to the power of 8, 4 to the power of 9, see which one matches. Now, if I do trial and error, I found out that 4, write that number down, trial and error, I did 4 to the power of 10 actually equals 1,048,576. So I tried 4 to the power of 8, didn't work. 4 to the power of 9, didn't work. 4 to the power of 10, it matches. So now I take my 2 equations, I look at them, the 2 things I got going on here. That means if 4 to the power of 10 equals this, and 4 to the power of n minus 1 equals that big number, well, that means I can match them up where actually 10 is equal to n minus 1. Right? Just matching them up. Everything matches here, the base, the number. Now the exponents match up where 10 is equal to that n minus 1. Now I can solve for n, because I'm going to bring that -1 over to the other side. Again, and change the sign. So it's going to be 10 plus 1. So there's actually 11 terms that we're adding up here. Put that over here. There we go. There's our 11. Now I have all the information I need to go into my summation formula. I'm not sure if I have all the room I need, but we'll see. We'll give it a go here. All right, so I get better, a little cramped here, so I'm going to pick a different color. All right, so S of 11 is what we're figuring out here, because I now know that is the 11th term, which means we have 11 terms. All right, so I'm going to sub in my information. A, it's a decimal, takes up room on me. All right, in the brackets, I have r to the power of n. So I'm going to have 4 to the power of 11. Oh, that's a big number. Minus 1 in brackets. And, of course, on the bottom, I have my r minus 1. So I'm going to have a 4 minus 1. All right. So, again, keep going here. So S11, sum of the 11 terms. Again, I have that decimal there, 0.0625. 4 to the power of 11 minus 1. I'm going to do that all at once because I'm running out of room here. 4 to the power 11. Whoa. That's 4,194,304 minus 1. So let's see here. So I take 1 off of that. So I'm going to have 4 million. Hopefully I can fit it in here. 194. And then what did I have again? 304, so I minus 1, it's going to be 303. Down to the bottom, 4 minus 1 is 3. All right, so finally, I can do all those calculations. And let's see here. My calculator going here. Minus 1. I think I messed it up on the note here. This is right though. All right, so I got that number times my decimal 0.0625 and then divide by 3. There we go. I'm getting 87,381.31. And there we go. So that is finding the sum of that series. Even though I didn't know how many terms there were at the beginning, I had to figure that out. That's something, again, we did with arithmetic series. But again, we had a different formula, so we had to use the general term of a geometric sequence to figure out how many terms there were, and then finally going back into our summation formula.